Dear ladies and gentlemen, let me introduce my colleague and myself. My colleague, Hasznosi Tamasné, is a primary physics teacher at Sashalmi Tanoda Primary School in Budapest. I'm Beata Jarosievitz, college professor at Denis Gábor College from Budapest, capital of Hungary. I teach physics and computing in the college. We are both grateful to school management because they let us to do this collaboration work between the primary school and the college. All physics experiments were controlled by us. We did them together in the school gym where 8th grade students were the presenters. We were very happy to work with these enthusiastic students from the primary school. During this presentation, we present some of the good examples of teaching a fundamental physics law called Newton's law. We have tried to present and discuss each law using different teaching methods, which can be adapted in face-to-face teaching and also online teaching during a pandemic period. Here I would like to mention that we chose this topic as inspiring reminder of the fact that Newton has also formulated his law during a pandemic period. All of us, we know that the ICT has revolutionized our work and daily life, and we are struggling with serious problems to motivate and encourage our students to use their devices for study, for physics measurements, and increase the popularity of physics classes. Analyzing many well-known facts, we formulated the following hypothesis. Hands-on activity engage students to form useful scientific concept. Exercise with real-life scenario brings students closer to science. Colorful digital classes rise up the lecture's tendencies. And we think that game-based learning motivates students to learn more. Finally, we expect that the non-formal and formal activity major changes will occur in students' attitudes to study, and our students will be much more interested and enthusiastic to learn and understand physics law. We are expecting the following: to make physics lesson more fun, to increase the connection between physics and daily life, and to focus more in students' learning based on experimental work. In this work, we use 3 different types of method: cooperation method, direct instructions, and inquiry-based learning. Participants of this activity presented were volunteer students of grade 8 from Sashalmi Tanoda Primary School, taught by my colleague, and my students from high school and college BSc level who were enrolled to compulsory physics classes and studied during the lockdown period. Unfortunately, I have never met my students personally. We have communicated only via the computer screen using MS Teams collaboration platform. During this cooperation, students work in groups of 2, 3. They were split in small groups and studied of the Newton's law, how, with different methods, and of course, with the experiments. During the cooperation, each group of students asked the same questions. Did you know about the 3 laws of Newton? Are about how and why things move, which has to be discussed as a main topic in small groups. Each group of students performed the experiment shown in the next video and started to predict and conclude about the law of inertia. Students realized that the object will remain at rest or in a uniform motion along a straight line unless acted upon by an external unbalanced force. Please look into the experiment and also make the conclusion. If the students struck so quickly the paper, the coin will go inside the glass. Newton's law of inertia can be observed here. While students also observe that the teddy bear will continue to move forward when the skateboard changes in speed or in direction. Same situation can be noticed when the apple will continue to move forward and the skateboard changes speed. Let's have a look what's going on first with the apple. The apple will continue to move forward when the skateboard changes its speed. Have a look what's going on with the teddy bear. Students also observe that the teddy bear will continue to move forward when the skateboard changes its speed and or direction. This fact also explains us why we should use the seat belt when driving in a car. Students get more close to everyday life discussing about the real problems. Students enjoy very much this experiment when they observe that the egg directly fell into the glass if the support was removed very quickly. You should try at home also to move the support quickly and follow the egg, what's going on. Law of inertia can be understood much better. In the following experiment, students concluded that the water bringing by one student continued to move forward and flow out of the dish when the students moved was blocked. Students better understood the law of inertia using cooperation method, co-learning strategies, and fun experiments. Have a look what's going on with the students blocked by other two students. Of course, very well, you can see the law of inertia. During the pandemic period, we became convinced that it is impossible to adequately teach some parts of physics without the use of experiments presented with simulation program. Using direct instruction methods, students try to play with given simulation and try to discuss and discover the physics law observed. One of the main advantages of the simulation is that it motivates students to learn and understand physics law without any dangerous experiments. These experiments can be done in front of the computer and they do not need any personal contact. If you would like, you can try to use this simulation to understand law of inertia. Inquiry-based learning is based on the constructivist conception of learning, starts by posing, questioning, making observation, creating prediction for the future study of the problems. This method is in contrast with the traditional education, where generally the teachers use to present facts and the new knowledges about the subject. All these expectations were embedded in the activity performed with the students. Before starting the experiments, students who did the physics experiment were taught about Sir Isaac Newton. It has been mentioned that according to a popular story, During the plague pandemic period, Newton was sitting in the garden on a sunny day and saw an apple fall from the tree. He was wondering why the apple or any object falls down on the ground rather the sideways or up into the air. After several years of questioning, he discovered the answer. With the presented experiments, students concluded that the acceleration of one object is dependent upon two variables, the net force acting upon the object and the mass of the object. In this project, inquiry-based learning was used for better understanding and study of Newton's second law. Look into this video, please, and realize that we use 3 different balls. Each ball has completely different mass, and this equipment has been set up at home. The girl tried to push out the ball, but of course, depending on the mass, the heaviest ball will be not able to get out. This explains Newton's second law. Students having approximately the same weight and height were selected, were roller skaters, and one of the students a skateboard. As they push each other by hands, you can see they both moved apart at approximately the same speed and covered the same distance. It was fun, and they love to present us the Newton's third law with this experiment done in the gym. You will see the girls, and here is a boy with a roller skate and skateboard. From the next experiment, we can observe the following, that until we apply equal but opposite forces, the rope is not moving. But when one force gets stronger than the other, the rope starts moving. We also demonstrate with the help of students Newton's third law. Wow. Well, with this experiment, Newton's third law can be demonstrated very easy if we focus on motion of the bottle started, rotated automatically. Why is motion? Why is moving? Guess why? This question has to be discussed in small groups. A special bottle was filled with water and had small outlets at the bottom. And this is a very fun experiment. You will see that the bottle starts rotating automatically. It's a very good demonstration of Newton's third law. The equipment being made at home. Well, please observe the following. Students has a balloon in their hands, and if we focus on the motion of the balloon, we understand how the balloons and rocket engine works. Newton's third law can be demonstrated very easily. A very similar experiment has been made with alcohol, butter, and lighting up the butter. You will see that the escaping gas travel at high speed in one direction, the impact pushing the rocket in the other direction, exactly in the opposite one. You can realize Newton's third law. It's very well demonstrated by the students. Finally, I can conclude that this work had a lot of positive effects. Both we are very happy to make this project together. Students enrolled in my physics course give me very positive feedback about the video experiments recorded for better understanding of Newton's law. Students who performed the experiments from the primary school will never forget Newton's law. They had a lot of fun and enjoyed the small show they made from the presentation. Based on the result and on personal interviews, we can conclude that our formulated hypotheses have been confirmed. We made physics lessons more fun, and we increased the connection between physics and everyday life. We think that our students involved in the activities became more motivated, enjoyed physics classes much better. Thank you very much for your attention. We look forward to hear some questions.